Hello friends, welcome back to my channel. So today we are going to see how to design the beams in RCDC. So in previous video we have imported the Etabs into the RCDC. So we'll continue with that same model. So here you can choose anything, design element, beams, columns, footing, which you want to do. So in that we'll pick the beam of suppose first floor, and then we have to click just create project. You can see now it's reading the analysis model, the data which we have import from the Etabs. So here you can see the data, all the things I have imported which is required for the beam from the analysis point of view. So here you can see the RCDC already made the grouping as per the standard. This I am just for showing demonstration. Before this we should import the slab data if we have designed the RCDC slab design. So these are the grouping, means it's taken the beam as a continuous. You can see the groups, so that is fully continuous. It's taken so that you can split according to our planning and the framing, because here the B11 it might be the mid landing beam, so it won't come in that level. So like that you can just ignore or split the group, and the ignore beam you can analyze manually also. So mostly beams and slab all the designers used to design manually or using Excel sheet. Mostly RCDC will be used for column and footing design, where the more complexity will come into picture. So you can split and you can group it again in RCDC. So if you want to export this framing, like you want to modify this frame, you can just save as a DXF file. It will go to the AutoCAD and you can do the modification in that. So in that modification you can show the bar markings and the schedule. It will help to make the beam schedule. And here you can see in the RCDC the beam marking has been done, like B1 B2 in zigzag manner. You can change from top to bottom or bottom to top as per you want. Mostly top to bottom is the procedure mostly people used to follow. Here you can change the name of the beam. And the part which I want to show you, like in file you can import the slab data. If you import the slab data, then the depth DF, depth of flange, will come as a slab thickness, or you can put it as manually also if you know the slab thickness already decided. So now we'll start with general and reinforcement setting. So here, if the torsion constant J is equal to 0.001 is defined in Etabs model, so here don't select ignore torsion option, and if it's not, then you can select this option. So after that is ductile design. So here we have to select this when we are considering earthquake, which is we are always used to consider. So only at supports we have to consider. So here in ductile design the code 13920 clauses will be incorporated, and here you can see the percentage steel as per 456. You can modify, or as per the project requirements also you can modify it. So this crack width check you can perform as well, which is given in IS code. These are the material properties which you can use from analysis, or you can modify it here as well. So these are the rebar settings, like from which range you are going to use the diameters of bar and up to its limit, like from minimum to maximum. And here is a stirrup spacing that you can modify according to the site conditions requirement and the codal clauses. So this is about the general setting. First is the very important for the beam design in RCDC. Then this second one, this one is the curtailment setting. For this you can refer IS 456 and IS 13920 if you want to do any changes. So here I am not changing anything. Now we'll go to the detailing and drawing setting. Mostly this section is not that much useful, and I will say not that much accurate. You can have an idea on it, like how the RCDC is showing the drawings, and later you can modify that drawings in AutoCAD as well. So here are the modifications, like rebar mark manager. You can change the here prefix for the rebar, how it will look when the drawing will be get printed. So this is mostly the drawing setting of the generated output. Next is the preferable spacing. You can see according to the beam weights, the spacing they have mentioned, the distance is between two bars. After this, there is a part in basic load cases. The load cases which we have defined in the Etabs, the same load cases has came here. So just we have to select here, means we have to tell RCDC like which type of load type this is. So for brickwork it's under dead load, and the dead load means the self weight, which it will also come under the dead load, and live load as a live load. This just we have to define. So in this our previous model there is no earthquake load we have defined, but for earthquake you can see here earthquake x z y direction is already there. So here only the difference is the x direction is x here, but the y and z are opposite used to get considered in RCDC. For y you have to select here z direction. So for load combinations you can add it from manually also, like from template, or from Etabs you can just add from analysis. So you have to select the load combinations and that's it. You have to press OK. So means the design will govern for these load combinations you have given to the RCDC. So we have started the design, and you can see it has designed all the beams, and the one failed beam group it's showing beam failure. So you can see here the beam, most beams are designed as a ductile and some of the beams are regular. So we can just go to its design setting and we can modify there its sizes and any other reinforcement, so that we can pass this beam. We can change here the grade, design parameters as well. So here I want to tell one thing, like here, so the beam we have not imported the slab and not defined any slab, so it is directly considering the rectangular beam. But mostly in practical the beam is monolithically casted with slab. So if you define the slab here, which by giving the thickness of depth of flange, so here the design will be got fully changed, where the beams will define as a TL beams according to the framing. So here just we are showing the beam design in RCDC. So here it's taken as a rectangular beam only. So here you can see the elevation and the other things are not that much accurate. If you see any designer drawing or GFC, it won't be like this. That's why we have to modify this, or we have to prefer our own template for this beam schedule. So here you can change the beam reinforcements also by clicking right click, and according to the zone you can see how much the ST is required and how much ST has been provided by the RCDC. So here you can increase the number of bars or diameter of bars based on your preferred spacing which you have been defined earlier. So this is according to the bending moment the ST required for the bottom left part, that is a 364.91 mm square came. Means that much is the minimum ST is required, or means we have to provide that much anyhow. So this bottom left, mid, right, the first layer is the bottom layer, and after that the second it's showing 312, means that is in the second layer of the beam from the bottom. So which bar is going continuous or which bar is getting discontinuous, we'll get the idea from here. And this is same for the top reinforcement. And here is the shear left, mid, right. So you can see the supports, the shear reinforcement is more because we are designing as a ductile. So you can see at the top ribbon there are many options, so we'll see now schedule type. So according to the groups and ungroup you can see the whole schedule. So you can see now it's came in the proper format which we used to see at the site GFC drawings. So this you can modify in AutoCAD and prepare one on A4, A3, A2 sheet. And after schedule, this is the elevation of some particular beams which we used to give generally a typical section in the sheet. So this will complete mostly of the beam schedule and elevation part. So you can just, by taking these two drawings, you can modify and make a beam schedule. After that, there are many options here, like bill of quantities. If contractor want to know the quantity of steel required for his pre-purchase, we can give it from here. And there are other parts like failure diagnostics, design summary, which includes according to the design code what are the steps have followed and what are the analysis values has been considered for the design. So we can cross check these values with our manual check as well. So these are summary, diagnostic and member forces, means for respective load combination what are the forces. So all things you will get of analysis as well. And these are the values we imported from the Etabs, means the analysis forces is from Etabs, and for the design load combination the design forces has came. So this is cover mostly of the topics in the RCDC as design and analysis perspective. There are some other customizations of the RCDC that you can look for your convenience and save the time, because these save lot of time of the manual calculation. But for this you have to cross verify with the manual calculation for better results, and you can save this RCDC file, means your results and all things design is got saved and you can open it anytime. And here you can see the beam size one which we have changed, it has that report as well. And if you want to do again some major changes, you can just unlock the design and do the respective changes and again auto design run it again, so it will go to its previous design input page. So this is for today RCDC beam. We'll see in the next